In this video, we're going to talk about the concept of z-scores. So this is also something that WebWork occasionally calls a standardized variable. There's a pretty simple calculation for it. The z-score, you just take an x value, subtract this value, this is a Greek letter mu for the mean, and divide by the standard deviation sigma. The notation in stats always gets a little weird, so don't overthink it too much. Just the z-score is equal to the x value you're given, subtract the mean, whatever that is in the problem, divide by the standard deviation, whatever that is in the problem. Those will just be given by web work or homework problems or whatever. So what does a z-score do? Well, it tells us the number of standard deviations that an x value is from the mean. So a positive score is above the mean, a negative score is below the mean. But let's just see how this works. So suppose I have some IQ scores here. I just generated these randomly. I did some statistics over here. There are 125 of them. No good reason. I just copied and pasted a random number generator down a ways. Now the population mean is supposed to be 100 with a standard deviation of 15. The population would be all people. So if we had IQ scores for every single person that has existed or could exist, hypothetically they would have a mean IQ score of 100 with a standard deviation of 15. But this is a random sample, so our sample mean is 100.8, which is just the average of these values. And the sample standard deviation is just the standard deviation, again, .s for sample of these values. So to calculate a z-score, you can do this in paper on a calculator, but I'm in Excel right now. So let's do equals. To put this formula in horizontally, I do need parentheses around the numerator. So I'll just click on x, and then I'll subtract the mean divided by the standard deviation. Well, which one? I have two means here and two standard deviations. Whatever one the WebWork problem gives you is the one you're going to use. In this case, I think it makes more sense to subtract the population mean because I know what that is, so it's a better number to use, and then I'll divide by the standard deviation. So I just did I2, which is this first number here, minus 100, all of that in parentheses, divide by 15. I get an IQ score of negative 0.632. And then if I copy this formula down, this one's negative 1.8, 1.226, 0.579, and so on. So what good is a z-score? Well, a z-score gives you a one-number summary of where a number is on the normal curve. So if you look over here, this is a normal curve drawn with a distribution of IQ scores. And down here, I've drawn a distribution of z-scores. You can see it has a mean of 0 and a standard deviation of 1. And if we actually check our z-scores we just calculated, we get a mean of 0.054, so pretty close, and a standard deviation of 1.04. So again, pretty close. It's a random sample, so this will not be exact, but it's very close. So if you have an IQ of 90.5, that means you are about right here, a little closer to the 85 than 100, and your z-score is negative 0.63. So on this one, you notice I scaled these so they're the same height and the same width, so they essentially look identical except for the axis label. But this negative 0.63 is right here. So whether you're talking about IQ scores, x values, or z-scores, which are standardized values, you're in the exact same place on the normal curve. That is, you're less than the mean because it's negative, but it's between 0 and 1, so you're in this range between 0 standard deviations and 1 below the mean. And this works for any of these values. This one is almost negative 1 exactly, 84.9. So you can see it works out to right around here, right around the negative 1. This one here, 129.4, has a z-score of 1.96, which is almost 2. So you can see 129.4 is right up here, and 2 is right here. So that's getting up pretty far into the tail. In terms of IQ scores, there aren't many people who would test this high in terms of IQ. So the really useful thing is just if someone gives you a z-score, you know exactly where you are on the normal curve. If someone told you they had an IQ score where the z-score was a 6, you'd say, okay, well, my plot here doesn't even go up to 6, it goes up to 3. 6 would be way, way out of bounds. If someone says something like that, you can just, tell them they're obviously lying. Just like if you hear someone say their IQ is 180, it's like, okay, well, that's way, way off the chart. Good for you if that's true, but I don't think that means anything. Anyway, so when you do all the problems with WebWork, just keep in mind that z-scores, standardized values, mean the same thing. Next video, we'll look into calculations with the normal model, which just keep in mind that every time you use z-scores, you'll set up your normal model to have mean 0, standard deviation 1.